With cutting-edge technology for their time, the Voyager spacecraft were not only scientific instruments but also symbolic ambassadors of Earth. Each was equipped with the iconic Golden Record, a photograph containing a curated collection of Earth sounds, music, images, and greetings in 55 languages, a cosmic message in a bottle intended for any intelligent life that might encounter them. From the moment of their launch, the Voyagers were humanity's first emissaries to the stars, built not only to explore but to communicate the essence of human civilization. Over 4 decades later, their mission has exceeded every expectation, becoming one of the most successful and enduring endeavors in the history of space exploration. Their journey has revolutionized our understanding of the solar system and extended humanity's presence into the dark and silent depths between the stars. Voyager 2 began its grand tour with a breathtaking encounter at Jupiter, capturing unprecedented images of the gas giant's chaotic storms, swirling cloud belts, and powerful magnetic environment. It studied the Great Red Spot in extraordinary detail and unveiled intricate interactions among Jupiter's moons and its faint ring system. From there it moved on to Saturn, providing the clearest views yet of the planet's magnificent rings, which proved to be far more complex than previously believed. Rather than static bands, the rings were dynamic systems filled with rapidly moving particles, braids, kinks, and mysterious gaps that hinted at gravitational interactions with unseen shepherd moons. This detailed observation completely reshaped scientific models of ring formation and behavior. Voyager 2's unique flight path enabled it to go beyond Saturn, something Voyager 1 could not achieve, and continue toward the more distant ice giants. In 1986, it became the first and only spacecraft to visit Uranus, revealing a pale blue world unlike any other. Uranus's bizarre 98 degrees axial tilt, essentially rolling around the Sun on its side, confounded astronomers. Voyager discovered 2 previously unknown rings and 11 new moons, mapping a frozen world dominated by frigid temperatures plunging to -353 degrees Fahrenheit. It also encountered a strange magnetic field, off-center and wildly tilted, which gave rise to mysterious plasmads and magnetic storms that offered rare insights into planetary magnetospheres. By 1989, Voyager 2 reached the final official stop on its planetary tour, Neptune. The data gathered during this leg was among the most stunning of the entire mission. Neptune's atmosphere, a rich, deep blue, was alive with the fastest winds ever recorded in the solar system, howling at speeds over 1,200 miles per hour. Voyager observed massive storms, including the now-vanished Great Dark Spot, and unveiled Neptune's ring system as thin and clumpy rather than continuous. But perhaps the most intriguing discovery came from Triton, Neptune's largest moon. With a retrograde orbit and surface temperatures nearing absolute zero, Triton defied expectations. Geysers of nitrogen ice erupted into its thin atmosphere, suggesting active geological processes and possibly a subsurface ocean, an enticing clue in the ongoing search for extraterrestrial life. Triton's complex surface, marked by cantaloupe-like terrain and frozen plains, hinted at dynamic evolution despite its distant, icy isolation. The magnetic field around Neptune also mirrored Uranus in its tilted, off-center configuration, forcing scientists to reconsider long-held assumptions about how planetary magnetic fields form and behave. The Voyager missions were only supposed to last 5 years, but they far outlived their planned lifespans. As the decades passed, these resilient spacecraft continued to function, each powered by a slowly decaying nuclear source producing less electricity than a standard household light bulb. Nevertheless, they continued to beam back data across the unimaginable distances of space. In 2012, Voyager 1 became the first human-made object to cross into interstellar space, breaking through the heliopause, the boundary where the solar wind from our Sun is overcome by the pressure of the interstellar medium. Voyager 2 followed in 2018, making it the second to breach this cosmic frontier and the only one to do so after directly passing through all 4 gas giants. In interstellar space, the spacecraft began to detect plasma waves and record the density of the surrounding medium, offering scientists their first direct measurements of this mysterious region. These readings were not just numbers. They were whispers from a place never before touched by human technology, revealing a space filled with electromagnetic waves and ionized particles, challenging the long-held notion that space beyond our solar bubble is empty. Yet the mission has not been without its challenges. The sheer distance, over 20 billion kilometers, means that signals take more than 18 hours to reach Earth. Communication requires pinpoint precision and extreme patience. One recent misstep underscored the mission's fragility. An incorrect command sent to Voyager 2 temporarily knocked it out of alignment, severing contact for nearly 10 days. At such a distance, the spacecraft was entirely on its own. Miraculously, NASA engineers managed to restore contact, a testament to the dedication, ingenuity, and skill of those still tending to this aging explorer. Each successful communication is not merely a technical achievement, it's a celebration of human persistence in the face of overwhelming odds. Voyager 2's contributions extend beyond planetary science. Its data has influenced the design of new missions and reinvigorated interest in ocean worlds such as Europa and Enceladus, icy moons that might harbor life beneath their frozen crusts. Its endurance and discoveries have paved the way for new searches for exoplanets and inspired a generation of scientists and engineers. Even as the spacecraft systems are slowly shut down to conserve power, the data it sends remains critical, its dwindling energy focused on the instruments most likely to yield insights from the interstellar medium. Perhaps the most iconic moment of the entire mission came not from an encounter with a distant planet but from a single photograph. In 1990, at the request of Carl Sagan, Voyager 1 turned its camera back toward Earth and snapped a now legendary image. Our planet appeared as a pale blue, just 0.12 pixels in size, floating in a sunbeam across the blackness of space. This image was a profound reminder of our tiny place in the vast cosmos. Sagan's poetic reflections on the photograph elevated it from mere data to a timeless meditation on the fragility of life and the unity of the human family. It became a symbol of humility, a call to cherish and protect our only home. Voyager 2, like its twin, carries with it more than just scientific instruments. It carries the story of humanity. The golden record it bears contains not only music by Bach and Chuck Berry but the heartbeat of a mother, the sound of laughter, greetings from children, and messages of peace. It is a snapshot of who we were when the spacecraft left Earth, a record of our species frozen in time and sent adrift into the infinite. That this artifact is still traveling silently through space speaks volumes about our aspirations. It reflects our desire not only to explore but to connect, to declare our presence to the universe with both humility and hope. Photographs taken by Voyager 2 of the outer planets remain some of the most breathtaking visuals ever captured. From the luminous clouds of Jupiter to the sapphire glow of Neptune, from Saturn's exquisite rings to the hauntingly cold beauty of Uranus, these images shape the way generations have envisioned the solar system. Yet perhaps the most stirring views are those from the fringes of the heliosphere, where sunlight fades and the stars begin to dominate the sky. These images hint at the next frontier, the unknown that lies ahead. As Voyager 2 sails ever farther from Earth, still transmitting, still working against all odds, it stands as both a technological triumph and a profound symbol. Each faint signal is a whisper across the darkness, a reminder that even as our machines age and their voices dim, their messages continue. Voyager 2's story is not only one of exploration but of endurance and inspiration. It embodies the spirit of curiosity that drives us to peer beyond our limitations, to seek meaning and knowledge in the silence of the stars. And even when it falls silent, as all things must, its journey will continue, its legacy etched into the annals of science and into the imagination of every generation that dares to look up at the night sky and wonder. Even as Voyager 2 drifts farther into the cosmic unknown, its journey continues to echo the deepest desires of the human spirit, to understand, to explore, and to endure. Its transmissions may be faint now, mere whispers across a gulf so vast that it defies comprehension, but each one is a testament to the resilience of both the spacecraft and the people who built and continue to support it. In a universe where stars are born and die in cycles lasting billions of years, Voyager 2 represents a fragile thread of consciousness stretching from a small blue planet out into the infinite. Long after the spacecraft ceases to function, it will continue on its path, unbound by gravity or planetary orbits, destined to wander the Milky Way for ages to come. Its radioactive power source will fade into silence, its instruments will go cold, and its golden record will remain intact, an eternal relic of a species that dared to dream beyond its atmosphere. At some unimaginable point in the far future, Voyager 2 may pass near another star system, its journey intersecting with celestial bodies as yet undiscovered. And though the odds of interception by intelligent life are vanishingly small, the very existence of the golden record is a profound expression of optimism, a belief that somewhere out there, perhaps millions or even billions of years from now, someone or something might listen. This dream was central to Carl Sagan and the team that designed the golden record. They believed that the act of reaching out, of sending our thoughts, our culture, our music and language, was in itself a meaningful gesture. In a time of geopolitical tension and environmental uncertainty, the Voyager mission was a rare point of unity, a project that transcended borders, ideologies, and generations. It brought together engineers, artists, linguists, astronomers, and dreamers in a collaborative effort to define what it means to be human. The recordings aboard Voyager 2 are a kind of mirror held up to our civilization at the dawn of the space age. They reveal not only our technological capabilities but our creativity, our diversity, our hopes, and our longing to connect with the cosmos. The voices recorded, some speaking in ancient tongues, others in modern dialects, say hello, offer peace, and express curiosity. These simple greetings ripple outward now, carried on a spacecraft that has outlasted nearly all of its creators, speaking not just to the stars but to future generations of humans who might one day follow its path. Voyager 2's continuing legacy is not just one of data and discovery but of inspiration. It has profoundly shaped our scientific understanding of planetary atmospheres, magnetic fields, ring systems, and moons, while also opening new questions about the formation and evolution of the solar system. Yet its influence reaches far beyond the scientific community. Artists, writers, philosophers, and musicians have drawn from its odyssey a renewed sense of perspective. Schools and museums across the globe display images and artifacts from the Voyager mission as symbols of what humanity can achieve when it pursues knowledge with integrity and imagination. In literature and film, Voyager 2 often appears as a metaphor for endurance, for solitude, for the human desire to transcend limitations. Its voyage is an epic tale written not in ink, but in mathematics, physics, and the silent poetry of deep space signals. There is a certain romance in the idea of a lone spacecraft navigating the cold darkness, holding within its frame a fragile echo of humanity, a romance that has captivated millions since the mission's inception. From an engineering standpoint, the continued operation of Voyager 2 is a staggering achievement. As its systems age, NASA engineers have had to develop increasingly ingenious methods to keep it functional. They've reprogrammed onboard software, rerouted tasks, and selectively deactivated instruments in order to preserve what little power remains. These efforts are akin to maintaining a vintage car in the middle of a desert with no spare parts, a feat made possible only by the dedication and brilliance of those involved. In many ways, the mission has become a living relic of an earlier era in spaceflight, operating on a platform that predates the modern internet, smartphones, and much of the digital age. And yet, despite its antiquated technology, Voyager 2 continues to yield scientific insights that no other mission can provide. It is our only direct probe in the southern hemisphere of the heliosphere and the only human-made object to study Uranus and Neptune up close. These unique vantage points have made it invaluable in mapping the boundaries of the solar system and understanding how our Sun interacts with the interstellar environment. In recent years, Voyager 2's instruments have continued to record fluctuations in plasma density and cosmic ray particles, giving researchers clues about the composition and behavior of interstellar space. These observations have challenged assumptions and introduced new models of the heliosphere's shape and its interactions with surrounding galactic forces. Data suggests the heliosphere